Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom Nama Budaya. Hello everyone, welcome back to my YouTube channel. In this video, I would like to tell you about polymeric materials with my lecturer, Profesor Dr. Tjokorda Tirta Nindhia, Sarjana Teknik, Magister Teknik. Before we start the presentation, let me introduce myself. My name is Nyoman Satria Dharmacayadi with name 22055311159. I'm from Udayana University, Teknik Engineering Faculty with Mechanical Engineering Department. The literature sources that I use the most on this video is electronic book Science of Engineering Materials Volume 2 Materials by Chanda. Table of contents that we discuss on this video are 4.11 Thermal Transition of Polymers, 4.12 Designing Polymer Structure for Improved Properties, 4.13 Composite Materials Incorporating Polymers. 4.11 Thermal Transition of Polymers. Thermal transition of polymer can be classified into 4 phases. Phase 1 is differential scanning calorimetry or DSG. Phase 2, thermal gravimetric analysis or TGA. Phase 3, differential thermal analysis or DTA. And the last, phase 4 is thermomechanical analysis or TMA. 4.12 Designing Polymer Structure for Improved Properties. For designing polymer for increase their properties, there's 3 basic principles of polymer. First is crystallization, second is increasing inherent stiffness of polymer molecules, and third, cross-linking. 4.13 Composite Materials Incorporating Polymers. This video is show us what is composite it is. What is composite? To understand what its material is composed of, let's take a closer look to its structure. It has at least 2 different components whose properties complement each other. The first is most of them made up of technical fibers, such as glass or carbon fibers, and it used to reinforce the strength of the product. This is referred to a reinforcement or fiber reinforcement. The second component is a binder. It can be a plastic or polymer resin. This metric ensures the cohesion of the structure. The material thus obtained have properties that the components on their own do not have. Let's take this example. For example, this car, in 5 years, it will be weighed 250 kilograms less and a low energy saving of 4 liter and per 100 kilometer. Furthermore, composite on the whole have the advantage of being very resistant and are much lighter than metals. Then, composite material incorporating polymers. Components of such material can belong to different material classes, such as metals, ceramics, glosses, and polymer. The best combination of strength and ductility can be achieved in composite consisting of fiber components embedded in a ductile matrix material. Embedded components may be in the form of particles and films. Under load, the matrix material tends to flow out, which creates frictional forces on the embedded component and contributes to the composite strength. First is bakelite. Bakelite is a phenolic resin filled with fillers used to improve its properties and reduce costs. Commonly used fillers are wood flour, fluff, cup rags, asbestos, glass fibers, and other fibers. Glass reinforced plastic or GRP. Glass reinforced plastic use glass fibers in the form of groovings, chopped strands, and mats to provide superior strength and resin for usually exposed or unsaturated polyester to transfer stress to the fibers. It is a composite material that reduces brittleness. Next, wood. Wood itself is a natural composite consisting of fibers of highly crystalline cellulose polymer. Within a matrix of line-in, the carbohydrate-free natural binder of cellulose fibers. Cellulose molecules are oriented along the fiber axis, resulting in maximum strength in that direction. Next, plywood. Plywood is a composite material made up of thin wood veneers bonded together with a synthetic resin, usually phenylformaldehyde or resorinical formaldehyde. Plywood absorb less water, and unlike straight grain softwood, it is even strong in all directions. It also has a better strength-to-weight ratio than metals, lower thermal expansion, and higher heat capacity. Vehicle tires. Vehicle tires are composite material containing woven cord reinforcement such as nylon and rayon to reinforce rubber. Cellular polymers or polymers foam cells are formed by the action of blowing agents at room temperature or during heat treatment of the polymer blend. The cell may be discrete, unit cell, or interconnected cell, depending largely on the time during which the blowing agent expands the polymer. 0.02 to 1 gram centimeter cubic. Some of the plastic are processed into foam plastic, such as polyethylene, polystyrene, polyvinyl chloride, polypropylene, polyurethane, cellulose acetate, phenolic resin, urea resin, silicone resin, and epoxy resin. Foam rubber is a multicellular. Okay, that's all about polymeric materials, part 4.11 until 4.13. See you in the next video. Bye!